All right, here we go with the topic in section 2.6 that is going to be a very important topic for every equation we practice solving this year. The topic is transformations. And this is kind of your introduction to that, but I'm going to preface this video by saying if you have absolutely any questions regarding this video and the topics on it or this lesson, please ask during class. But we are going to talk about transforming, which basically means changing linear functions. Now, to begin with, I'm going to start with the linear parent function that we discussed in a prior video. The linear parent function is y equals x. And if we were to graph this, you all understand, I hope, that it has a y-intercept of 0. There's a plus 0 at the end, and the number in front is the slope, which is 1. So the slope is 1. So if I was to graph this, the y-intercept is 0, 0, and then I go over 1 and up 1, over 1 and up 1, over 1 and up 1, roughly on my smartboard slightly off a little bit. But roughly you get a graph that looks like this. Please memorize that graph. This graph right here is the linear parent function. It goes at a 45-degree angle. Linear parent function looks like that. And we're going to use this graph to transform all the functions this unit. Everything we do will alter that graph. And what do I mean by alter? Well, what I mean by alter is this. Anytime you add, subtract, multiply, and divide this equation by certain numbers, it will affect what happens with that graph. So for instance, if I write y equals x plus 2, this plus 2 will have an effect on that graph. If I write y equals 5x plus 2, if I put a 5 here, that 5 will also affect the graph somehow. It will transform it. And so basically, transforming is what is the effect that these numbers have on the graph, and that is what you have to learn. Now I'm going to write that up here. Basically, transforming is asking the question, what effect on the graph does add, subtract, multiply, and divide have on that graph? And that's what we're going to talk about here during this video. All right, let's talk about the first type of transformation. It's called a translation. Another word for translation is the word slide. What slide means is that you don't turn it, flip it, rotate it. All you do is slide the graph from one spot to another. Every function all year long will have one of two types of translations. Either it will be a horizontal shift of the graph or a vertical shift of the graph. Now, how does it work? Let's talk about horizontal shifts first. Whenever you take a function f that has the variable x in it, in order to shift a graph to the left, inside the parentheses next to the x, there is a number called plus h, whatever that is. Plus h will move the graph left however many units or however big h is. Now this works opposite of what you think. Plus you normally think move to the right, but it doesn't work that way. In this case, plus will move to the left. Please memorize that. If I want to move the graph to the right, inside the parentheses, I will put minus whatever number I want next to the x. If it's x minus h, this will move the graph to the right. So please make sure that you understand that and memorize that. Let's talk vertical shift. Vertical is up and down. How do you get a graph to move up and down? Well, what you do is you take the entire function f of x, whatever that is, the entire function, and at the very end, outside of the parentheses, you put a number like plus k, whatever k is. But if it's a plus k, this will move the graph up. If you take the entire function and at the very end put a minus k, that minus number will move the graph down. So it's crucial to memorize that, and I'm going to go over the basics one more time with you. To move a graph horizontally left, you add a number inside the parentheses. To move the graph to the right, you subtract a number inside the parentheses next to the letter x. If you're going to move the graph up, you add a number at the very end outside the parentheses. And if you're going to move a graph down, you minus a number at the very end outside parentheses. Please, if you don't understand that, please make sure you ask during class. All right, now let's look at a couple of examples. First of all, let's actually look at a graph. Now, we already talked about the parent function, y equals x. And I'm going to regraph this again. Again, it's got a y-intercept of 0, 0. And we go over 1 and up 1, over 1 and up 1. And our parent function looks something like that. So this is the graph that we are going to transform. And how are we going to do that? Well, down in letter B, what it says is, let's do a vertical shift of this graph by -3. Well, I'm going to go back a slide, if I can do that. Okay, a vertical shift down. What moves the graph down is to put the number at the very end of the function and subtract it. Okay, well, let's go back to our function. Our original function is the parent function, y equals x. So I'm going to write y equals x. Or in other words, I'm going to erase that. I'm going to put f of x equals x. That's our function. And then if that x is in parentheses, to move the graph down, we put the -3 outside it at the very end, which obviously becomes the function x minus 3. And this particular function, since it's got a -3 at the end, should move the graph down. But that -3 we know is the y-intercept. Oops, -3. Y-intercept is -3. And it's got a slope of 1. I'm going to write that over here on the left. It's got a slope of 1. So if I was to graph that, my y-intercept starts down here at -3, but I still go up 1 and over 1, up 1 and over 1. And there, roughly, is my graph in blue of my transformed function. Now, if you notice, it looks exactly the same as the one up top. The only difference is the y-intercept value has moved down 3 spots. And therefore, that is how you affect a graph. So this worked exactly like we thought it was going to. All right, finally, let's look at some word problems. If you're told f of x is equal to x minus 7, I want to know what is the function's equation if it is horizontally shifted a. 3 units left. All right, well, I got to go back. 3 units left. If I'm going to go to the left, here it is, I need to add the number inside the parentheses next to the x. Okay, well, let's go back to our problem here. So I'm going to take my original function, here it is right here, f of x equals x minus 7, and I'm going to call the transform function f prime. This little mark up here means prime. And what I'm going to do is I'm going to take my x and put it in parentheses, and then I'm going to put the minus 7 way at the end. Why did I do that? Because since it's being shifted horizontally left 3 units, Inside the parentheses next to the x, I need to put that plus 3 to get it to go to the left. Now, if I actually combine my like terms and rewrite this equation, f prime of x is equal to x minus 4, which is the transform function which will shift it 3 units to the left. How about 4 units to the right? Well, I'm going to go back a couple slides again. If I can do that, there we go. To the right. Moving the graph to the right means put the number inside the parentheses, but I need to minus it off. Okay, well, that means I take my original function, f of x equals x minus 7, and what I'm going to do is call my transform function f prime. I'm going to put the x in the parentheses, the minus 7 at the end, and now I'm going to go to the right 4 units, which means put a minus 4 in the parentheses next to the x. Well, if I combine this whole thing together, I would get f prime of x equals x minus 11. And that's the graph or the equation that would shift my original function up top 4 units to the right. I hope that makes sense. That's how I want you to do your assignments. And if you got questions, let's discuss it in class.